Alright guys, so this one right here, Model 3, you should have read the little paragraphs, and we're going to work through the questions. So it says, using Model 3 as a guide, what are the reactants of cellular respiration? In other words, what molecules go into cellular respiration? So the reactants, things that go in, is going to be glucose, right here, and oxygen, right here. Okay? And then the next question says, what are the molecular products? So the things that it shoots out at the end is carbon dioxide and water. So you may be thinking, oh, these molecules sound familiar. That's because these are the same products and reactants as photosynthesis in the reverse order. So in cellular respiration, it takes in glucose and oxygen. That's, us, we eat food and we breathe oxygen, and we give off carbon dioxide and water. So you might be like, oh, how do my cells give off water? It can be water vapor, it can be water in your bloodstream, different things like that. So number 3, write the full chemical equation for cellular respiration. So all you're going to do is take the reactants, and the products, and that's all it is. So I'm going to do a very bad job at trying to sketch this for you, okay? So it's going to take 6 glucose molecules, so C6H12O6. 6 glucose molecules and 6 oxygen molecules, and it's going to give off 6 carbon dioxide molecules and that was so bad. 6 water molecules. Okay, here we go. So this is balanced. There's 6 glucose, 6 oxygen, 6 this, 6 that. So remember, photosynthesis is just the exact opposite. It would just go the other way. All right. So in cellular respiration, the energy stored in glucose molecules is released and stored in which energy-rich molecule? The cell's charged battery the cells use to do the work. So the energy-rich, the full battery, is going to be right here. This full battery is ATP. Looks so bad, sorry. All right. So it says once ATP is used for cellular work, it breaks into the lower energy ADP molecule and inorganic phosphate. Based on model 2 and 3, what does the cell do with low energy ADP plus P? It just recycles it. It recycles it to make more ATP. It just keeps reusing. So ADP has 2 phosphates. Let me stay in the frame. 2 phosphates, and then we have this extra phosphate. So it booms together and it makes the ATP. And the ATP, once it gets broken, then it just like reduces down to this right here, and then it just bops right back, and then bops right back, and then bops right back. So it takes that glucose and it just keeps the cycle going. So it says through number 6, through the process of cellular respiration, 36 to 38 ADP molecules are converted to 36 to 38 ATP. So every time that these cells go through this process, so ADP goes through and comes out ATP, the ADP starts here. It's doing that to 36, on average 36 to 38 ADP, and 36 to 38 ATP come out. So it's not just doing this to 1 at a time. That would wear your cells out. It's doing 36 at a time. So it wants you to label. So right here, you're going to label ADP and ATP. So number 7 says, write the full equation for cellular respiration, including ADP and ATP. So all you have to do is the equation that you already did. You're just going to add 36 ADP plus P plus all this stuff that's already there, and you give off 36 ATP ATP. All right. So in your own words, describe the process and the function of cellular respiration. The whole process is that it breaks down glucose, it releases that energy, and then it traps that energy as ATP. Because ATP is the only way that your cells can use the energy. They can't use glucose as energy. They have to use it. They have to convert it into ATP. So it breaks down glucose, releases the energy, and stores it as ATP. If I'm talking too fast, always just like pause the video. All right, list at least 2 variables that might influence the rate of cellular respiration. So you would have things like the amount of glucose available. So like if you're starving, you're not going to have as much glucose available. That's going to slow down cellular respiration. The pH of your bloodstream would slow this down. The temperature of your body could slow this down. Any of those things. So 10, carbon dioxide is toxic to your cells, yet cells produce it through the essential process of cellular respiration. We know that we're getting carbon dioxide out at the end. Thus, the CO2 that is produced must be removed from your cells. Considering what you know about your own body, what happens to the carbon dioxide that your cells produce? You breathe it out. That's it.